Now we will continue with the special distributions. The second distribution is the uniform distribution. In this case, we are going to denote this by the random variable x is distributed uniform, and we use the two parameters a and b. Okay. The setting is a uniform random variable that takes values in an interval a and b. These two numbers are in the real line. Is a completely random number between a and b. More formally, this means that any two subintervals of the same length have the same probability, which results in a PDF that is constant over the interval. The PDF is this one. A uniform random variable x continuous on the interval a and b is defining as having this PDF 1 over b minus a for values between a and b and 0 otherwise. So the function will looks like we have x, we have the PDF, we have the height being 1 over b minus a, and if we have a over here and b over here, the function is going to be like this. Oh, no. So we have a over here and we have b. The function will look like this. It's a line of height 1 over b minus a for values between a and b. And 0 in other case. So the CDF is given by this equation. Remember that CDF is the probability of x being less or equal than x. And we have that is a stepwise function. So for x less than a is going to be 0. So it's like this. For x between a and b is this line. This is a function of a line, and it's going to be something like this. When x is in b, the value is 1. For x being greater than b is 1. So this is the CDF. Okay. Now the mean and the variance. So the mean expected value of x is going to be a plus b over 2. That is the midpoint. Expected value is over here. Remember, is the center of mass. And the variance is going to be b minus a squared over 12. Okay. Let's see the proof. We're going to do the proof for the expected value. So the expected value of x, remember by definition, is the integral from minus infinity to infinity of x times f of x dx. But we replace this minus infinity and infinity just to integrate over the support of the function. In this case is a and b. So between a and b of x times the PDF, in this case is 1 over b minus a dx. Okay, so we can take out the constant, in this case b minus a, and it's the integral from a and b of x dx. Okay, but this integral is 1 over b minus a, and the integral is 1 over 2 x squared evaluated in b between a and b, and this is equal to 1. We can take out the 2, so it's 2 times b minus a, and evaluate the x. It's b squared minus a squared, and if we do some algebra here, this is actually, oh, sorry. This is actually equal to 1 over 2 b minus a. And if we factorize this, is b minus a times b plus a. And if we cancel out this and this, and this is equal to b, or it's the same, a plus b or b plus a is commutative over 2. And that is the proof. Okay. If you want to check the proof for the variance, the proof is on pages 145, 146. Okay, in case you are interested. It's not necessary, but if you want to check all the process to get this formula, you can read those pages. Okay, let's see an example. Suppose that our random variable u is uniform with parameters a equal to -6 and b equal to 4. We have to sketch the PDF of u and calculate this probability without using calculus or algebra. So, well, algebra, yeah, we are using algebra, but we are not using calculus. We are not using integrals. We can, but for the example, we are going to don't use the integrals. So we have that our values u are between, let's say we have 0 here, and this we have the PDF of u, and we have the values -6, let's say we have -3, we have 4 over here. So the PDF will look like this. Will look like something like this. We have -6, we have 4, and the height of this is, remember, this height is 1 over b minus a. In this case is 1 over b minus a. In this case is 1 over 10, right? 4 minus 6 is 4 plus 6, that is 10. Okay, so in case you want the formula, you can calculate this. F of u is going to be 1 over b minus a, and is 1 over 4 plus 6, that is 1 over 10. This is for u located between -6 and 4. In other case, it's 0. Okay, now we want the probability that u is greater than -4, right? So remember that, let's say we have -4 over here. The probability is the integral of, then the integral is the area below the curve. So we have to calculate this area, right? Remember that this height is important. This height over here is 1 over 10. So we have to calculate this area from -4 to 4 of this CDF. Well, in this case, we can see that we have 8 numbers from -4 to 4. I mean, it's easier to see that the integral of all the PDF is going to be 1, right? And we have that the height of this rectangle is going to be 1 over 10. So that means the width is going to be 10, because the multiplication between the area of the rectangle is width times the length times the height, sorry. And it's going to be 10 times 1 over 10, that give us 1. So what is the area of this red rectangle? Well, the area is going to be, in this case, the height is going to be 8 times 1 over 10, right? That is 8 over 10. So this probability is 8 times 1 over 10. That is 0.8. Okay. Now, how do we find the probability of u less than minus 2, given that u is greater than minus 4? So this probability here is over the new rectangle, because we are given that u is greater than minus 4. So we are on the red rectangle. And we want to find what is the probability that u is less than 2. So that is the probability. We have minus 2 over here. That is, what is this probability? What is this area? What is the area of that rectangle? So to find that, we can use the formula or the definition of the conditional distribution. That is, what is the probability that we have u is less than minus 2 and u is greater than minus 4 over the probability that u is greater than minus 4, right? And the probability of the denominator is the area of this pink rectangle, and this area is going to be 2 times 1 over 8, 1 over 10, because the width is going to be 2 and the height is 1 over 10. Okay, the width is because we have two numbers. We have minus 4 and minus 2. We have 2. So, and the height is 1 over 10. So that probability is 2 over 10. And the probability of u being greater than minus 4 is actually the red rectangle. So this is going to be 8 over 10. And this probability is 2 over 8. That is 1 over 4. Okay, this is calculating the probabilities without calculus, but we can also use the integrals in case you find it easier.